All right, so let's start over. Today, we're going to be learning Python. You will not need your Raspberry Pi. I'm glad that Allie got hers to work. Oops. And, yeah, so we're going to be learning Python so that next week we can control Minecraft using Python. So that's really what we're working towards, which is pretty exciting. And we're going to be doing that on our Pi. And you can see that Python is actually already on your Pi. It's the icon called IDLE, I-D-L-E, which stands for Interactive Development Environment. The DL is development. And we're not going to be using that this week. We're going to be learning Python a little bit differently, but we will be using that next week when we use Python to control Minecraft. All right. So let's go ahead. I wanted to start the class today while watching this video. I think this is a wonderful video. We're already 1 minute and 28 seconds into it at the beginning of this webinar. So you guys weren't seeing it. So it's an introduction of why studying computer science is important, kind of what you can do with it. And it's just, I think, a great intro into studying programming.
What do you want to be when you grow up, Olivia? An astronaut.
I want to be a fashion designer.
A basketball player.
I want to be an actor.
A doctor.
A teacher.
A chef.
An artist. What do you want to be when you grow up? A mermaid.
Do you know what a computer programmer is?
Yeah, no.
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 I think it's something that has codes and is able to decode a mystery.
I think that they...
Wait, what?
Computer programmer?
No.
Nowadays, just about everything requires some form of programming. So, what is it? Programming is basically explaining to a computer what you want it to do for you.
When you're programming, you're teaching possibly the stupidest thing in the entire universe, a computer, how to do something.
Programming is one of the only things in the world that you can do where you can sit down and just make something completely new from scratch, whatever you want.
It's really not unlike kind of playing an instrument or something, or playing a sport. It starts out being very intimidating, but you kind of get the hang of it over time.
Coding is something that can be learned, and I know it can be intimidating. A lot of things are intimidating, but what isn't?
A lot of the coding that people do is actually fairly simple. It's more about the process of breaking down problems than sort of coming up with complicated algorithms as people traditionally think about it.
Well, if it's fairly simple, why aren't there more of us doing it? Over the next 10 years, there will be 1.4 million jobs in computer science, and only about 400,000 grads qualified for those jobs. That's a shortage of 1 million people. So, how do you start?
I was obsessed with maps when I was a kid, and cities specifically. So I taught myself how to program. I had a very clear goal of what I wanted to do, which is to see a map of the city on my screen and play with it, put things on the map, move things around the map, see what was happening in the city, how it worked, how it lived, how it breathed.
The best early thing was actually using software to decide when the classes in my school would meet, and that put me in a position to decide which girls were in my class.
The first program I wrote asked things like, what's your favorite color? Or how old are you?
I first learned how to make a green circle and a red square appear on the screen.
The first time I actually had something come up and say, hello world, and I made a computer do that. It was just astonishing.
When I finally learned a little bit of programming, that blank wall resolved into a bunch of doors. And you open them, and finally you start to open enough doors that the light comes in. And to me, a finished program is like a structure filled with light. All the corners are illuminated. You understand the structure of it. It's a really serene feeling to have completed that.
It took me some time to realize that creating things with your hands or creating code, creating programs, is just a different way to express creativity. I think right now there's a big emergence of the culture of making. People who make their own scarves and hats, people who write their own apps.
Now it's just limited by your imagination and sort of what kinds of ideas what kind of understanding can you build into the computer so that it can do these things that were previously impossible?
All great things are built in teams when you collaborate with other smart people.
You're testing your ideas, you're stimulating each other. That's what makes us successful. It's not some flash of brilliance by somebody who then codes 24 hours a day for 3 weeks. It's what happened. The magic happens when we're all on the same page, collaborating and building something together.
There's a much greater need in the world for engineers and people who can write code than there will ever be supply. And so we all live these very charmed lives. To get the very best people, we try to make the office as awesome as possible.
We have a fantastic chef,
Free food,
breakfast, lunch, and dinner.
free laundry,
snacks, even places to play and video games and scooters. There's all these kind of interesting things around the office and places where people can play or relax or go to think or play music or be creative.
I went on the Bureau of Labor Statistics for the United States, and there's about a third of the pie that's all the things you would expect. It's they're working in the government, they're working in typical technology jobs, but then like the rest of the pie, it was the majority of the pie, just split down into these little teeny slices of every industry imaginable. And what it is computers are everywhere. You want to work in agriculture? Do you want to work in entertainment? Do you want to work in manufacturing? It's just all over.
Here we are, 2013. We all depend on technology to communicate, to bank, information, and none of us know how to read and write code.
So you guys, what else? Who else has an idea of what we can change with our programming? What else can we do? Tiffany?
What I saw my students take away from using Scratch and programming in our classroom is that they were willing to push through problems. It really builds critical thinking, it builds problem solving, and it's something that they can then apply to math in the classroom or their reading skills. We integrated science with this programming, and I saw my scores go up 30%.
When I was in school, I was in this after-school group called the Whiz Kids, and when people found out, they laughed at me, and
I would like to now call our group the Whiz Kids.
these things, and I'm like, man, I don't care. I think it's cool, and I'm learning a lot, and
I think y'all are cool.
Some of my friends have jobs.
It's important for these kids. It should be mandatory to be a citizen on this planet, to read and write code.
I just think you have to start small, right? And I think that's one of the biggest misconceptions about computer science and programming overall is that you have to learn this big body of information before you can do anything.
You don't have to be a genius to know how to code. You need to be determined.
Addition, subtraction, that's about it.
You should probably know your multiplication tables.
You don't have to be a genius to code. Do you have to be a genius to read? Do you have to be a genius to do math? No. No. I think
think if someone had told me that software is really about humanity, that it's really about helping people by using computer technology, it would have changed my outlook a lot earlier.
Whether you're trying to make a lot of money or whether you just want to change the world, computer programming is an incredibly empowering skill to learn.
To be able to actually come up with an idea and then see it in your hands and then be able to press a button and have it be in millions of people's hands. I think we're the first generation in the world that's really ever had that kind of experience.
The programmers of tomorrow are the wizards of the future. You're going to look like you have magic powers compared to everybody else.
I think it's amazing. I think it's the closest thing we have to a superpower.
Great coders are today's rock stars. That's it.
So code.org is a wonderful website, and many of you may have been to code.org. They host something called Hour of Code, which I know a lot of schools participate in. We are not going to be using code.org this evening, but I think it's a good thing to look at. Let me go ahead and exit out of here. Did anyone have anything they wanted to point out about the video? Anything that they found interesting or surprising, or that they thought was cool? I loved hearing about all the different ways that you could use, computer programming, agriculture. They showed 3D printing. They showed self-parking cars. Anyone that surprised you? Any guests that surprised you? Yeah, I agree, Rachel. That was cool. That was will.i.am from the Black Eyed Peas. And I kind of wonder how he got involved with this video, but it was neat, and I liked what he had to say. He said that everyone should have to code. It should be like to be a citizen, you have to code. And I don't know if I, agree that strongly with him, as kind of he agreed. But I do really agree with the sentiment that, we are a wired people, and by that I just mean that we are really connected with the digital world, everything, our finances, our entertainment, everything. So wired people need to know something about wires, and that's a quote that I love. Just talks about how we need to understand how our digital devices work, since we rely on them so heavily and they've become so easy to use. I don't think that's right. If you mean that everyone should have to code, I agree. It's not even everyone can read and write. I think everyone should be given the opportunity to learn to code. That would be very cool. Alright, so before we jump into practicing our Python skills, I want to go over an introduction to kind of what programming is. So if you guys remember, a few weeks back, we talked about computation. We talked about what it meant to be a computer, and that the term computer came from computation. So what is computation? There are two kind of big fields of thought: declarative thought and imperative thought. So if you are studying for, let's say, a history test, and you are memorizing dates, like when the Constitution was signed, or who was, a world leader during World War II. When you're memorizing facts, that's using declarative knowledge. This is this. It's memorization, it's knowing a fact. Imperative knowledge is being able to come up with a solution, understanding the procedure of how getting an answer works. So for example, 43 plus 57, not just knowing the answer of 43 plus 57, which is 100, but knowing procedurally how to get the answer of adding any two-digit number together. So you don't memorize that 43 plus 57 is 100. you procedurally understand, based on math class, how to get that answer. It's the difference between knowing what the square root of 4 is and knowing how to get the square root of any number. So who knows what the square root of 4 is? Can you raise your hand? Type in the response. We'll get some typed in responses here. We'll just go with those. 2. Yes, the square root of 4 is 2. Do I have a brave soul who wants to explain how they know that the square root of 4 is 2? Hey, Rachel.
Well, 2 times 2 is 4, and the square root is when something is like multiplied by itself to get that number.
Great. Thank you, Rachel. So, Rachel said, she knows that 2 times 2 is 4, and the definition of the square root of 4 is a number that when times by itself equals 4. So, square root of 4 is 2. Also could be negative 2, since negative 2 times negative 2 is 4, but 2 will work just fine. So, it's pretty easy at the beginning to learn kind of through guessing and checking or simple memorization what the early square roots are. So the square root of 9 is 3 because 3 times 3 is 9. We know that. Square root of 16 is 4 because 4 times 4 is 16 and we know that. But when you get up to the really, really big numbers, you actually don't know procedurally offhand how to get that number, and I'll show you. There's an algorithm that mathematicians can use to find the square root of any number. And the way that an algorithm works, and we can look up what the definition of algorithm is, it's like a special complicated math equation that gets run. It's like a procedure on how to solve a problem. So you can't just run it once, you kind of have to run it multiple times. So we're not going to get too much into the theory of algorithms or square roots, but basically what computation is being able to come up with the recipe, in the case of math, the algorithm, but we're going to focus back now, bigger picture, being able to come up with the recipe or instructions to solve a big problem. And having an end test, knowing when you are finished. Bear with me one moment. So I just did some quick math. So if we used that fancy algorithm to find the square root of 111,556, we would get the answer 334. And we would know that that answer was correct because we could multiply 334 times 334 and get 111,556. Right. I just chose a random number. But in programming, we're going to design programs to solve problems, whether it be Hangman or a game, an app. And you're going to have to come up with the recipe or the list of instructions for the computer to follow in order to run the program correctly. You're also going to need to know how do you know that the program is being run correctly. So if you're playing Hangman, and after so many guesses the computer says you won, well, how can you guarantee that the program is running correctly, that you actually won? And that there's not just a bug in your code that says that you won. So if you guys can think back to the history of computers, when computers started, they were built to solve one problem. It was called a fixed program computer, and that you couldn't change their function after they were built. They were built to perform a certain function. Nowadays, we use what are called stored program computers, in which they're designed to take different sequences of instructions and execute them. So basically, we can pass them any sort of program, and they'll be able to execute it. So a program is like a recipe. It's a sequence of instructions that the computer follows. And computer programmers write these programs in programming languages. Admiral Grace Hopper created the compiler, which is that special kind of computer program that translates between language that humans understand, or programming languages, and language that your computer understands, or machine language. But we're just going to be focusing on programming languages. Specifically, we're going to be focusing on Python. So I have this, bullet here, understanding the thought process. And the reason that I want to bring that up is that, yes, we are learning Python right now, and we have practiced in Scratch. But it's more important that you understand the thought process behind how Python works, behind how, if-then and conditional statements work, how looping works. Understanding those things is really what we're after. And practicing those in Scratch and practicing those in Python is going to better help you across the board. Even when, let's say you get to school to study computer science and there's a whole new programming language everyone's using, being able, practicing using Python and Scratch is going to help you. And Python is what's called a high-level programming language. Low-level programming languages would be like writing on tapes, or just, not quite, but like the really, really old ones that were difficult to write. High-level programming languages are like Python, and they're written in such a way that's almost like human English. The last thing that we're going to talk about is syntax versus semantics. So you might hear these words surrounding computer programming, so I kind of wanted to briefly go over them now. If you have an error in syntax and you are programming, what that means is that something is wrong with either, like, quote unquote, the grammar or the mechanics of your line of code, or it just doesn't follow the rules that Python expects. So let's take a look at this example of, making the analogy of using the English language as opposed to programming language. So this English sentence would be considered a syntax error, quote unquote, because it doesn't follow the rules of the English language to make a sentence. The cat yellow. Who can tell me why this doesn't make a sentence? The cat yellow. Why is that not a sentence? It's got a capital T. It's got a period. No verb. Wonderful. Oh, I just saw your hand go up. I'm sorry. I saw some typed responses. There is no verb. That is correct. So it's not following the rules of the English language, so that would be a syntax error. These are pretty easy to find because you can just see maybe you misspelled a word, maybe you put the wrong punctuation in terms of programming, but it's just, an error in the actual things that you're typing. Semantics errors are errors in logic. So let's look at this first example. The cat is table. Well, this is technically a sentence. It has a noun and it has a verb, it has a capital T and a period, but the sentence is meaningless. The cat is table does not have meaning, or at least not meaning to most people in general society. Okay. You could also have a semantic error in which the sentence has meaning, but it's wrong. So the cat is on the table. You say that, but really the cat's not on the table, it's really on the floor. This last example, this is super hard to catch, especially when you're doing something like a math algorithm and you really don't know what the answer is. You're really hoping that your computer program gets it right. So it's hard to spot semantic errors. It's much easier to spot the errors in your punctuation or syntax errors. Any questions on this? All right, let's move on. We're going to go ahead and actually start coding now. So to do that, I want you guys to sign up with Codecademy. I'm going to sign out. So I'm going to send this link out to everybody. I'm going to send it out in chat. Oh no, Allie, I'm sorry. I'm just seeing all of these chats now. You can't answer questions because I made you an organizer. Oh dear. Well, let's see. Is there a way I can make you not an organizer? No, there's not. I'll keep an eye on my chat, Allie, to see if you have any questions. Cool, we're in a special organizer club. All right. Woo! Codecademy! Kids excited. I'm excited. So, you do have to make an account, but you can just use your Gmail email that you made for this class. I'm going to username and password. I wouldn't use your last name, your first and last name, and your username, but honestly, Codecademy is super safe, especially if you do not sign up, don't use Facebook or social media, but you just use this regular sign up. Hey, Allie, you know that your video is on. I can turn it off. I think you have to turn it off. All right, I'm turning it off. Sorry, Allie. Okay. So you guys should sign up. And when you sign up, it's going to ask you, what are you interested in learning? And I want you to pick the option, no worries, Allie, all the way to the right, the option that says, you know what, don't give me any suggestions. It's all the way, there should be 3 options. Choose the one all the way to the right. And it should bring you to a home page. You could make your username anything. You could make your username like Allie, Allie loves coding, or mine is Tar Heel Teach, I think, because I went to UNC Chapel Hill and I am a teacher. I just try to make my username not include my first and last name. And okay, it's still not taking me to the home page, which is frustrating. Here we go. So that your home page should look something like this. And I want you to scroll down to under language skills where you see Python. All right, I'm going to give everybody a moment to catch up, but basically we made an account. We clicked on the option all the way to the right. There are going to be 3 options available. They won't look like this. 3 options. They're like, hey, do you want to learn about web development? Do you want, to increase your job skills? Or do you want no options? Click on the no options, and then you'll get to a home page that looks like this. You'll want to scroll down to language skills and find Python. And we're going to give everybody a minute to catch up. Ooh, Caitlin? Or Kate? Sorry. Kate says hi, but specifically just to Allie's face. Alright, so I'm just giving everybody a moment to catch up. Grace, you can absolutely start. I'm going to kind of walk you guys through it for 10 minutes and then let you guys go at your own pace. But if you feel pretty comfortable, maybe you've worked on programming before, you can get started. And you'll get started on Python syntax. But for those of you who kind of want to follow along with me, I'm going to get started in just a moment. For those of you watching the recording, you get to follow along with me. Alright, so we're going to go ahead and get started. Hannah, we're not messing around with Minecraft next lesson. We're going to mess around with Minecraft next week. Alright, so we're going to start with Python syntax. Yeah, you could also press start. It would just start you here. And it's going to kind of give you a tour of the environment. So it'll say, welcome, Python, gives you this. And something might actually pop up on your screen. Since I've already completed this lesson, it's not going to pop up on my screen again. But basically, in this upper left-hand corner, you'll see information about different coding, just kind of hard to describe, definitions or different types of or functions that you're learning, data types. It just gives you general information like a lesson. And it's not a lot. You just got to read, and I really, really cannot emphasize this enough. You really should be reading what's up here because you might be able to finish what's over on this gray area without reading absolutely every line over here. But when it comes to next week and we're in Minecraft, that gets challenging pretty fast. And so it's really going to help you if you take your time and do all of this. All right. So this kind of intro just says Python is a programming language. It's used in many things. Are you ready to start? In every lesson, you'll have specific instructions that tells you how to complete this lesson, how to get to the next lesson. This one, it just says click Save and Submit. And there'll also be hints for many of the lessons. You're going to type in this gray area, and kind of the quote-unquote solution, or what pops up for the user to see, will be in this small black box. So go ahead and when you're ready, hit Save and Submit Code. And welcome to Python, printed up here for our user to see. I'm going to start the next lesson. Alright, so in this lesson, I already have my solution written there. Again, I've already gone through these. But we are going to learn about variables. And we can read this here. Creating web apps, games, and search engines all involve storing and working with different types of data. They do so using variables. A variable stores a piece of data and gives it a specific name. The way I like to think about variables is thinking about them like a cardboard box that you put a label on. And then you can put things inside the box, like you could put a number, or you could put a word. And you can change what's in your box. The label is the variable name, and the item that goes in the box is, whatever is on the right of this equal sign. So, in this example, the variable spam stores the number 5. And it goes variable name, assignment operator, the equal sign, and then the number. So now we're going to set the variable, my variable, equal to the value 10. And hit save and submit. My variable is the label, it's a box, the label on it that says my variable, and we're storing the number 10 inside that box. So, Booleans, I'm going to delete these answers here and we can go through it. If you guys remember from Scratch, we actually used Booleans before, we just may not have called them that. When you're using something like an if statement to check on a condition, you're checking to see if that condition is true or if it is false. It cannot be in the middle. It is either true or it is false. Black and white. So either the user is clicking the right arrow key or the user is not. And that's that kind of data type is called a Boolean. So a Boolean is like a light switch. It can only have 2 values. Just like a light switch can only be on or off, a Boolean can only be true or false. So those kind of conditions that we were checking with if-then statements could reduce down to a Boolean. So, is the right arrow key being pressed? Could reduce down to either true or false. But you can store these words, true and false, each that start with that capital letter, 2 different variables. So we're going to store the value 7 to my int. Now, this is just instructions to move to the next lesson. My int equals 7. My float equals 1.23. And that int actually stands for integer. And that float stands for floating point number. And these are different kinds of numbers that Python registers. And my bool for Boolean set to true. So once you guys have that typed, you're going to hit save and submit code and move to the next lesson. And from kind of here on out, I want you guys to move at your own speed, making sure to read everything on the left and the instructions before moving on. I'm going to be here to answer any questions. But in these last moments of class, I want you guys to move at your own speed. And make sure you're reading the information, reading the instructions, and just move your way through Codecademy. But I will still be here, I just might not be talking the whole time. So again, just to reiterate what we're kind of doing right now, I know you can't hear me. I want you guys to move at your own pace through Codecademy as opposed to moving with me. You guys seem to be a very independent bunch, so I think that'll be okay. But I'm going to stay on the line just as the class continues. I do want you to work until the end, until 8 p.m. And if you have a question, I can jump to that specific lesson and kind of help you through it.